Hello everyone, this is Streamer and welcome to Genius Math Minds. In this video, we have a problem from the mathematical induction. So we are going to prove this statement by using mathematical induction. So that's what this is. So the question is, prove that 7 power n minus 3 power n is divisible by 4 for every n greater than 0 and n belongs to natural numbers. So first we need to know what n is. So this n can be 1, 2, 3 and so on. So since this is a natural number and it is greater than 0, so that is the first thing. So we should know what that variable means. So n is starting from 1 till natural numbers, so all natural numbers. So the next thing is we need to write it as an equation or expression. So how we can write that is p of n equal to 7 power n minus 3 power n. And what the statement is, it is divisible by 4. So we can write it as 4m, and m can be an integer. So that's what we have here. So this 7 power n minus 3 power n can be written as a multiple of 4. So that's what this statement is. For every mathematical induction, we know that there is a basic step called, or the basic step where we put n equal to 1. So let's check if n equal to 1 satisfies this expression. So p of 1 equal to, you need to put n as 1 here. So 7 power 1 minus 3 power 1. This gives 7 minus 3. 4. 4 is divisible by 4. So this statement is correct. So step 1, we can say it is perfect or it satisfies the given expression. Now the next thing, we need to assume p of k is true. So this is an assuming step. So we need not prove anything. So if p of k, then p of k equal to put k instead of n. So we have 7 power k minus 3 power k. Since this is an assuming step, we can assume that 7 power k minus 3 power k will give us something like 4r. Let's take that. So here r can be any integers. So this is what we have. So this expression, let's take a step as the equation 1. So 7 power k minus 3 power k equals 4r. So this 4r is just showing that this expression is divisible by 4. So that's what this does. So that is the assuming step. So we know this, the equation we got from this equation, we need to use this in the step 3 so that we can prove the statement. So now the step 3 is, this is the proving step. So we need to put n equal to k plus 1. So this is the third step and the final step. So p of k plus 1 equals 7 power k plus 1. So instead of n, we are putting k plus 1 minus 3 power k plus 1. So this is what we have here. If we prove that this is divisible by 4 in a form like 4 times 4x, we can say. So if we prove this expression is divisible by 4, then the proof is over. So then we would have completed the proof. So for that, we need to use this expression here. 7 power k minus 3 power k equals 4r. So how do we use that? That is what mathematical induction needs, the manipulation or the computation of expressions. So how we can get that is, we can split this 7 power k plus 1 as 7 power k times 7. Since if the base was same, we can add the power. So that's why we have written 7 power k plus 1 as 7 power k minus 7. Same way, we can split this as 3 power k times 3. So if we get this expression again, if we say this expression is divisible by 4, then the proof is over. So how we can say that is 7 power k times 7 power k times 7 minus 3 power k. We need to get this expression 7 power k minus 3 power k. How do we get that is, we can write this 3 as 7 minus 4. Why we write this is, we can distribute this as 7 power k times 7 minus 3 power k times 7 plus, because minus times minus gives plus, 3 power k plus 3 power k times 4. So we can write this expression as this. Why we are writing this is, here we can clearly see that if we take this 7 as common, then 7 power k minus 3 power k, which is the equation we have here, will be there in this expression. So that's why we are doing this manipulation. For every problem, this may change. So this 7 minus 4 is for this problem. Again, if we see this term right here, this term is already divisible by 4 because it has a multiplied 4. So that's why we have put 7 minus 4. One term which is this divisible by 4. So this will be one term, and this term will be the term here. So that's why we have 7 minus 4 here. So if we take 7 common from the first two terms, 7 from these two terms, we will have 7 power k minus 3 power k plus 4 times 3 power k. Why we have this? Because here 7 power k minus 3 power k, we have assumed that it is equal to 4r. So we can substitute the value here. 7 times 4r plus 4 times 3 power k. Now this is 4 times 7, or we can take 4 from these terms. If we take 4, we have 7r plus 3 power k. Now we can clearly see this term is divisible by 4. So we have taken p of k plus 1. Since p of k plus 1 is divisible by 4, then this expression is complete and this proof is complete. So now we can say, by mathematical induction, this statement, that is 7 power n minus 3 power n, is divisible by 4, and that's the end of the proof. So this is what the manipulation step is. The step 3 is where the manipulation step is, because we need to use the expression we got from the step 2. So that's why this computation is important. So that's it about this problem. Thank you.